Okay, so normally when we're talking about measuring an angle, we measure it in degrees. Okay? There's another way to measure angles and it's radians. So 1 radian is the amount of the angle if you have a radius here, and your arc is the same distance as your radius. That's 1 radian. Okay? It's or. Or here, and or from here to here. Okay? So like if your radius is 5, this would be 5, and this would also be 5. That's 1 radian.
Is that always though?
Is that always?
Yeah, like 2 radians give you like 2 radians and equal to the outside.
No, that's not all, but...
Oh, that's it, breaking it down into...
Exactly, in little parts. Okay? So the full circle in degrees is 360 degrees. In radians, it's 2 pi radians. Okay? What's important in this is that if 2 pi radians is 360, what's 180? 1 pi radians, exactly. Okay? Now, you know from complex numbers, we were dealing with radians. Do you remember that? Sine a pi over 3, a pi over 2. That's just the angle measured in radians instead of measured in degrees. Okay? So, if we want to convert, so 180 degrees is pi radians. What about if I had 270 degrees? Okay? What you're going to do is 270 divided by 180, and you're going to see how many times 180 goes in there. And it comes out as 3 over 2. So that's 3 pi over 2 radians.
Why did you put over 180?
Because you're trying to see how many 180s go into 270, because 180 is pi. Okay? 360 is how many 180s go in. Okay? So to convert from degrees to radians, divide by 180. Okay? Now, when we did area and volume, we worked with the length of an arc and the area of a sector, but we only worked with it in degrees. Now we're also going to look at the formula in radians as well, okay? And in your log tables, it gives you both formulas. Can I get rid of the board? So this is my sector, okay? This is the angle, there's your R, and that's your L. So if I go to my area and volume in my log tables, I get this here on page 9, okay? That you have when theta is in degrees or when theta is in radians. So you're given both formulae there, okay? So if we wanted the area of a sector, can you remember what it is?
It was like
Theta over 360 by area pi r squared. That's in degrees. In radians, it's a half r squared theta. And the length, this is all given to you. The length of the arc used to be theta over 360. And now it's just r theta. So let's do an example of that.
So chunk the area of sectors, what's equal to it in radians?
This is it in radians, exactly. This is degrees, and this is radians. So the radius of a circle is 8 centimeters. Find the angle at the center of the circle subtended by an arc of length 10. So you could draw yourself a little picture. Your radius is 10. Your length of the arc, your radius is 8, your length of the arc is 10. And we're looking for the angle. Because we're dealing with radians here, we're going to do it the radian way, okay?
What's that right there?
What's?
Of the circle, and then that word.
Find the angle at center of the circle subtended by an arc. That just means there's your arc there. Find the angle. Okay? Now, we're looking for the angle and we have the length. So we know the length of the arc is r theta. So the length 10 is equal to 8 times theta. So that means theta is 10 over 8 radians. Okay, which is 5 over 4 radians. It's just a bit quicker to do it this way rather than doing it this way. Okay.
For radians, so does the length of the radius now have to be like the same as...
That's what 1 radian is. Okay? In this case, we 5 over 4 radians. That's how big the angle is.
Okay.
Okay?
So how would you know that you...
Which to use. If they want the answer in radians, they have to say it. Okay? So it's totally up to you other than that. Alright? Generally, if they're using pi over 4, they're looking for the answer back in radians. So like, if I just do part 2 of this, it gives the angle in radians, so then you're going to use the radian formula. But if you did convert it to degrees, that's totally fine too. Like, they have to be very specific on the way they want the answer. Okay? And generally, they don't ask for it in radians. Can I just do part 2 of this question? So find Find the length of the arc if the angle subtended at the centre of the circle is pi over 4. Okay, so again my radius is 8, but this time they're giving me the angle, which is pi over 4. They gave me the angle in radians, so I'm just going to use that formula. So the length of the arc is r times theta. So in this case, it's 8 times pi over 4. So the length of the arc is 2 pi. Okay, and did I say centimeters at the beginning?
Yeah.
So that would be 2 pi centimeters. Okay, so your angle, you put radians after it because that's like a measurement. It's like the degree sign, it's radians. But if it's not an angle, then it's just 2 pi. Yeah?
You know, if you're given the centre of a circle, like, you know, you said the centre is pi over 4.
The angle,
So, like, does that matter, like, how, like, big it is, does the angle change all the time as well?
the angle can change, yeah. Yeah, so like in this scenario is pi over 4.
Okay.
Okay, but it could be anything. It depends on the size of the sector.
Yeah, the size of the sector will change the angle.
Oh yeah, so like pi over 4 is 180 over 4, it's 45. And I just drew it as if I drew the last one. But you could definitely, like, you could draw it a bit more accurate than the 100%. But yeah, it changes each time. Is that okay? Okay. Just very quickly, because we talked about converting from degrees to radians. What about the other way? Express 2 pi over 5 radians in degrees. Can you remember from complex numbers what used to we say pi is?
180.
That's simply it. 2 by 180 over 5. Okay? 210 degrees. Oh, sorry. What am I doing? 72 degrees. Don't know. Okay, so just instead of your pi, you're putting 180. That's really important. Pi radians, 180 degrees, and you can just transfer between them.
When do you know that it's 180 instead of pi? Just when they say radians?
If they say, so if it has pi in it, it's in radians.
Yeah, but like, how do you know to put 180 into that instead of just like putting that into calculator and then pressing like the change?
Oh yeah, when we're talking about angles, we never use the pi button on the calculator. Okay, so if it's an angle, if it's cos of an angle, sine of an angle, or like this, if it's an angle in a circle, it's always pi is 180. If you want to use the pi button on your calculator as radians, your calculator needs to be in radians. So do you remember that little D up the top? That's for degrees. You can change your calculator into radians, shift mode, and then you can see number 4 is radians. Okay? But generally I like to stay away from that because we can just do this and then we never need to mess with our calculator.
And then like with the last answer, like how come you do need to put 180 into that?
Because this is the length of an arc,
Oh, okay, so it's not-
so it's not an angle. Yeah, so I just leave it as 2 pi. Okay?